So coming up first is the Crust Network. And who remembers their first journey into like building on the blockchain? Because I'm going to tell you my anecdote there, and it's going to be somewhat embarrassing. The first mistake I did, and honestly I feel like everybody makes, is that they're like, oh, perfect, I'm going to store all my data on the blockchain. That's great, knowing very little about what you're doing. And then, after spending a whole ton of KETH, maybe RETH or whatever testnet you're on, ETH, you go down this whole decentralized storage rabbit hole, and you kind of get to like, oh, we're not actually there yet. But decentralized storage, and especially in the last 5 years that I've been talking about, has made huge strides. And we have great teams like the Crust Network who are building on there. And specifically, currently in this next talk, we have Zikun Fan to talk about his work with them and the Crust Network.
Okay, thank you, Jesse, and thank you so much. Hey guys, good evening from Shanghai. This is Crust Network on Polkadot Decoded 2021, and my name is Zikun Fan, the tech lead of Crust. And today I'm going to show you the decentralized storage on Web3 to show you how Crust Network combined with the biggest decentralized storage network, IPFS, and the most potential blockchain, Polkadot. So let's just start. So first, I want to give you a high level about Crust Network. So generally speaking, Crust provides a decentralized storage network of Web3 ecosystem, and its protocol stack is an incentive layer beyond the IPFS network. And simply to say, Crust encourages us to provide our personal computers storage resource and gain the blockchain reward. So beyond this too, and Crust has already provide a usable and runnable storage market to let any user can store any data. So, and it is already go live on Crust Maxwell preview network. So next, I will give you a very concrete example to show how user can deploy a website in the Crust network with simple operations. So step one, just show this demo is creating a website by using the React script. It will take several seconds. Yeah. Okay, it's done. And next, I will just open this website and change the text by typing hello, Polkadot Decoded 2021. Okay, it's done. Then I just build it. And next, I will just go to the most important step is go to the Crust apps, and you will find it provides a standard IPFS functionalities, and it can let us to ping our website into the IPFS. Yeah, and next, I will just place a storage order, and this is an on-chain interface. Yeah, it just send an extrinsic. Okay, it's done. Yeah, that's all I need to do is ping IPFS, upload to IPFS, and place the storage order. And the final step is access our website. And this demo, the magic is I just use my laptop and a Crust account, and I can create a website, can access everywhere in this planet. So, okay. So now everyone should have a very intuitive image about how to store data on Crust Network. And I can give you a very quickly conclusion about the demo. As you can see, it's very easy to allow user to store data on Crust. It only takes 3 steps. Step 1, ping the website through the IPFS. And the step 2 is place a storage order through the on-chain decentralized storage market module provided by the Crust Network. And yeah, it's done. And then the final step is access your website everywhere with the IPFS prefix or the HTTPS prefix. So now everybody may have a question, right, on how this magic works. And this graph shows the simplest working flow about the whole story. So after user ping and place a storage order, the storage nodes on Crust Network will know, okay, there is a new order, and the node will start pulling the user's data through the IPFS protocol, and then it will sell the data so that the protocol, the Crust protocol, can know, oh, the node, you indeed store the data. And finally, the node will report it to chain to tell the chain, oh, I just store the data. And after the chain verified the node's speaking, and the whole process is done, and the user can say, oh, some nodes store my data. So this is the whole process. And the next part, I'm going to show you the current apps on Crust. So the first is the Web3 ecosystem, and we now have Uniswap and SushiSwap on the Define ecosystem, and of course the Polkadot apps also on Crust, and the IPFS docs is also on Crust. And this cases is not just a contribution from us, from our side. They have already integrated with Crust storage in their daily deploy process. And that means every time you just visit this website, the Uniswap website, the Polkadot apps, and the IPFS docs, and the content mostly comes from the Crust network. Yeah, and there is also a lot of benefits to host the website on IPFS and Crust, such as to prevent the DNS hijack and provide a high availabilities, because there is a 3,000 storage nodes on Crust Maxwell preview network. And that's also the goal and the hope of a decentralized storage. Okay, and Crust users, okay, I'm sorry. And Crust users are not only come from the Web3 ecosystem, they are also have Web2 ecosystem. There are two projects which respectively represent the customers and the business end. One is cow transfer and another is kitty. As for the cow transfer, it's super much like WeTransfer, and it has 6 PB user data, and it has 45 million users, and its page view is 130 million, and its users distributed among over 140 countries. And this is for the customers end. As for the business end, we have kitty. Kitty actually is a video. It provides a video store service based on IPFS and Crust. And its business is automatically connect the traffic informations and to provide the image and video AI service for China's transportation sector. And it serves for the Chinese government. And besides that, we got lots of user cases and applications incoming, such as all those NFT projects like Really, and it is integrating with Crust for decentralized storage solution. Also, Thinso, as you can see there, and it provides a medical data storage and a sharing service based on IPFS and Crust. And here is the portfolio, and we also launched Crust grants program, like the Web3 grants program, to accelerate those projects, those decentralized storage applications. And we will talk the grants in the later slides, okay? So after we talk so many about their two applications, so let's focus on Crust protocol itself and take a look. So as you can see, Crust protocol stack divided into 3 layers. The first layer is called MPOW, Meaningful Proof of Work. It just shows in the whole story process, the demos, and it quantify and inspect the node's storage status and assign a work report to check. And the second layer is called GPOS, Guaranteed Proof of Stake, and it is a consensus and the blockchain reward protocol. And the third layer is called DSM, Decentralized Storage Markets. and it provides a single but most important on-chain application interface. Is called the place storage order, and to let user can store any data through the IPFS protocol. Okay, let's just go a little bit deeper on this. As for the MPOW, and it divided into two parts. The off-chain part is called Sworker. It provides a thinning process and a challenging service to sell the file and continuous challenging the local file, and periodically sign a work report to chain. As for the on-chain part, when the chain receives the work report, it will verify the work report, including verify the file's root hash and the file state transition. As for the GPOS, and generally speaking, each node's storage volume will transfer into the stake limit. And of course, the GPOS, the design idea derived from the NPOS, but with the stake limit. And the stake limit comes from the node's storage volume. And also, the node's self-staking and other guaranteed staking cannot exceed the stake limit. As for the exiting part, it cannot get any reward for both validators and its guarantors. And this GPOS mechanism means the whole economic system will balance both POS and POW, and it will adjust itself automatically to achieve a dynamic balance between the POW and the POS. And as for the design of the DSM, of course, place storage order is the only on-chain interface. But in fact, the core of the DSM is to provide an on-chain negotiation mechanism. Okay, so next, let me give you guys some highlights about Crust Protocol stack. The first highlight is Crust scaling process is super fast. As for the benchmark about scaling data is 32 gigabyte data only takes 1 to 2 minutes for HDD disk. As for the SSD disk, it only takes like 10 seconds. So you can just store big data, but without any feelings about its scaling process. And the second highlight is Crust Network is super cheap. As if you just store 1 terabyte data for half a year, only cost you $1 to $2. Okay, the third highlight is Crust Network is super easy to join because we do not require any hardware. Any devices with TEE can just join. And the fourth thing is for the GPOS part, because this GPOS protocol provides and give the miners and the token holders can cooperate with each other. And the miners can just provide the storage and the token holders can just guarantee it's the node. Okay, so so next part I want to share with you is our ecosystem. So decentralized storage is a super big topic. We cannot achieve our goal by ourselves. So let's see what we have done. The first is, of course, the Polkadot ecosystem, our parachain plan. And of course, we're very confident to be the first slots parachain on Kusama. And because since the Rococo V0, we have joined and tested the XCM demo with Akala, with Fala, and with Darwinia and other parachains. We do the demo. And the second one is we launched our shadow network to join the Kusama's auction to provide a standard XCM module, X storage for the parachains to store their data, like the Darwinian's NFT data can just cross the chain to store on Crust. And the third thing about our parachain plan is shadow network is not an independent network. It will connect with mainnet. And currently, we will connect the shadow network with our Maxwell network to manage the storage orders for the whole parachain ecosystem. And the next thing I just mentioned before is Crust grants. And Crust grants aim to accelerate a decentralized project, and it provides 5-dimension support. The first dimension is the money, of course. We can funding support up to 30 grants USDT. And the second is the grants project can deep participate in the Crust technology community and has opportunities to be invited to the Crust ecologies events to make bigger influence. And the third dimension is can have a chance to deeply participate in the Web3 ecosystem and get support from both Polkadot and IPFS ecosystem. And the fourth dimension is the grants can get the free storage space. And the last dimension is the project team can have a chance to be connected with more token funds and capitals. Okay, so next is foundation and communities. And Crust has joined these big name foundations like Linux Foundation, CCC, like Confidential Computing Consortium, and it provides the TEE technology advisor services for Crust to join. And the second one is the Apache Foundation, the TCLAB community. It's also a confidential computing communities. And the third thing is the third thing is we have already joined the Rust Chinese community to promote the Rust language. Okay, last but not least is the cloud. As you can see, we have already got cooperation with Microsoft Azure, and Azure will provide 4 types of services. The first is to provide the Crust chain node service in the Azure's marketplace. And the second one is Azure will provide a very high cost efficiency storage service based on Azure's virtual display, Azure Blob. And the third thing is we will create more IPFS public gateways on Azure. And also Azure already provides an IPFS public gateway named ipfs.azurewebsites.net, and we will provide more IPFS public gateways and donate to IPFS communities. And the fourth thing is Azure will provide a Crust cloud mining service, and miners can just start within 5 minutes on Azure. Okay, so that's all I want to share with you guys today. And thanks to the Web3 Foundation and the Parity Take, and of course, Polkadot Network and the Decoded conference. And thank you guys so much. And please feel free to ask me anything. Yeah.
Oh, awesome. What a fantastic presentation. And we do have a bunch of questions here. So, if you're ready, let's get right into the first one. So the first one comes from, awesome. The first one comes from NL. And is Crust planning to set up a data marketplace / analysis services, or is it just storage?
I'm sorry, I just missed your question. Sorry.
Oh, not a problem. So is Crust planning to set up data marketplaces and analysis services, or is it just for storage mainly?
Actually, Crust provides the decentralized storage market and provides a standard IPFS storage interfaces like IPFS get and IPFS put. After you just store the data and place a storage order, the nodes on Crust Network will store your data and provides the retrieval services. Yeah.
Fantastic. I think we have time for a few more. This one comes from Harold Heckman. And how do you verify on-chain that hosts really store the data such that only the honest acting storage providers are rewarded?
Okay, so the process, like I just go to the former slides, the whole process. Okay. Oh, it's there, yeah. And after user just place a storage order, the storage nodes on Crust Network will just pull the user's data through the IPFS protocol, and it will seal the data within the TEE program, and the TEE program cannot be changed. Nobody can change the TEE's program. So the TEE's the TEE program will seal the file within the TEE and will record, okay, the node has already stored the data, and it will sign a work report, and the work report will send it to chain, and the chain will verify the work report by verify the file's root hash and the file's state transition and the storage and the local storage size checking. Yeah.
Awesome. And we actually have time for one last question, and this comes from MC Escher,
okay.
And it's how does stuff like Crust compare to things like Filecoin? And I think somebody else mentioned SIA, but mainly Filecoin seemed to be getting a lot of likes there.
Yes. And this is the most popular question. So we're comparing Crust with Filecoin. So actually, we are both provide the incentive layer. The same thing is we both provide this incentive layer beyond the IPFS network. But the different thing is Filecoin using the ZK's knowledge to their consensus beyond the PoS-derived, proof of spacetime, and proof of replica. But Crust using the different technologies, it's TEE, and it's guaranteed by the hardware, and its sealing process is super faster than the Filecoin. Like I just mentioned before, if Filecoin want to sell the 32 gigabyte data, it will take, if you use the Lotus or the Venus client, it will take like 1 hour. So you cannot imagine when a user just store a website, the user will wait for 1 hour to say, okay, my data is on chain. But as for the Crust Network, it will only take 1 to 2 minutes. So the user can say, oh, my data is on chain. So based on this technology, and we have already provided a storage market, which mentioned in the Filecoin's white paper in the early version. So it allows user to store any data. Any user can store any data through the way, and this storage market is unlimited and free. Yes.
That's amazing. Thank you so much.